Hello everyone, I think we've got enough of you in now, so we'll get going. So welcome to another Arch & Z webinar. We've got an exciting one today going through some feature extraction functionality within BricsCAD. So I'm going to introduce Sean to you, and then he's going to give us a talk which is about 40 minutes long, and then we'll do some questions at the end. So as always, if you have any questions as we're going, please put them in the questions tab, and we will answer them at the end. So we're very lucky to have Sean with us today. He has a lot of experience. He has over 25 years experience in the world of CAM, BIM, GIS, engineering, survey and design. He's a civil engineer by training with experience working on lots of different environments, including bridges, tunnels, hydrology and highways. He has had a strong focus on configuring software for local design and documentation standards with quite an extensive experience in implementation, customization, training, project management, and consultative methodologies for specific business goals. So quite a lot there. I will now hand over to Sean, and he will start sharing his screen. Over to you, Sean.
Great. Okay, well guys, great to be here. This is a topic that I really enjoy presenting because it's one of the newer and more interactive features that we've put out quite recently. It's also one of these deceptively complex scenarios that we often skip over. So before I start, let me just point out that everything I show here today, you can find more detail on our website. So if you go to bricsys.com, you will see under news, there's a blog, there's also other webinars on these topics. On the learn and support tab, there's a whole bunch of materials on everything from migrating to BricsCAD to the actual technical details of each function. Also, we're focusing today on scan to BIM and scan to CAD for buildings. We do surveying as well, which is what I normally do. So on the survey side, we've got a whole workflow on scan to tin, which is quite extensive and quite impressive. So happy to come back to this at some other stage, or if you search online, you'll find plenty of details. And if you need to get in touch with me, always happy to go into more detail on these things. On the point cloud side, we've been doing them for quite some time. And when we open the software, you'll see that BricsCAD is quite quick at bringing in point clouds. We've done many different variations on the process. So again, on the website, you'll see many point cloud workflows with different scenarios. The one we're focusing on today is under the BIM package. On the BIM package, we've got plenty of options for general geometry, for documentation, etc. You can see all these on this website here. Under reality capture, you will see scan to BIM, which is the one that we usually talk about, and also scan to plan. So what we found interesting is that while we love the whole BIM workflow, a lot of people still need to produce plan views. So if you're doing fit outs or just basic services in a small building, people tend to work off plan views still. So what we do is a little bit of both here. So this first drawing file we're looking at here, this is one version of the finished product. So you can see the plan view has been created. In this case, the dimensions are in model space. So if I was to go into model space here and grab one of these are standard CAD dimensions that you always use. So the client in this case was happy to just generate the geometry from our process and then manually put in dimensions, the standard process afterwards. So that's available, of course. This is the point cloud that we're going to use. So this is the finished version. So as we do this, you'll see that I use the structure browser quite a lot. This is like a hierarchical view where you can effectively see every element in the drawing file. So I can, for example, grab my point cloud here and click on hide, which is just a quicker way instead of freezing a layer. What I can also do, let me just show that again. I can instead hide my building. So this is the original point cloud here. So it's a standard, it's one floor of a reasonably large building. And if I turn this back on, you will see that what we generated is the walls, windows, doors, and floors of that. So we have this model available for IFC export. We also produce a whole bunch of sections from it. This is the section that we produce. So you'll see in this case, we've got different color schemes turned on for our final view. In this case, the dimensions are in paper space. So we're going to use, instead of using standard CAD dimensions, we use these BIM dimensions to automate it. So you can do either. We encourage you to use the automated versions, but if people prefer to use the standard CAD options, they're also available. So that's just to give you a taste of what we will get done with this session. Let's give a brief overview of how BricsCAD works. So we're using the BIM workspace for today's session. There is a standard drafting workspace. So if you're doing 2D type work, you have all the usual commands for lines, circles, arcs, layer controls, etc. People tend to migrate to this very, very easily because things like sheet sets and plot styles just come across from existing CAD platforms. We won't go into the 2D CAD side today, but that's what we're normally known for in the market. What we're really promoting today is some of more complex workflows. So we go back to the BIM workspace. One thing that we should quickly emphasize here is that in BricsCAD, when you've got a solid object, so I've just drawn let me just erase this and redraw. I'll use the primitives command here to draw a basic box. As you hover over this, you can press the control key and pick on an individual face. And then you can use the quad here to do operations. So all the edit operations are in the ribbon, but everything can be done from the quad as well. So as you hover over an object, you can use this quad to access commands. So in this case, I'm clicking on one of the faces and moving it around. I can also grab one of the edges, do a longer click and move that with the manipulator. And because I've got dynamic UCS turned on down here, if I now do a rectangle, I can draw on this face. And after I've drawn on that face, sorry, I just snapped. Let me do that again. Let me draw something here. And now what I can do is select that opening and do a push pull around there. And there's many variations on how this is done, but it's a free form modeling option that lets you produce all kinds of interactive views. So one of the sample files that we ship with is this villa here. So you can go and create creative type shapes like that very easily from these functions. We're not going to do much of that today, or any of it really. I wanted just to mention it to make you aware of it. What we will do is use some of the quick draw commands. We'll use quick draw and quick wall. So on quick draw, if I go and select here, I can draw some kind of a basic building outline. And what this gives me is the walls and the slab of a very simple building. If I was to keep on going with this, I can draw internal walls. As I do this, you will see that I have the option to type in specific offsets from existing walls to make it more accurate. And then when I move outside my footprint, the walls get trimmed. If I was to hover the mouse, so I'm touching one of the existing walls, I can then go and cut through that wall. What you'll also see is that as I click along here, we have these magnetic snaps where it extends the existing walls and leaves us interactively work off the same grid. So last point on this is that if I do the opposite, where I snap from the outside and work in, you can see I create a recess. So what we'll do today is we'll refer to this command. We'll also use the quick wall command to create these interactively from a point cloud. And the very last point to mention before we start here is that if I was doing this manually, if I was drawing walls using one of the more standard commands, these are initially just solid solid entities. What I can do is use the quad and go to the BIM area and classify these as walls. And once they've been classified, they get a whole bunch of IFC properties. So if I was to export to IFC, these are then used. Now, when we use these quick commands, the IFC properties are automatically added. So this wall, for example, is classified as a wall by default. That's because I use the quick draw command, so it's got enough intelligence to assign these automatically. So that's just to give you a very, very quick taste of what the objects look like. So as I create them from the point cloud, you'll know what we're doing. We've got a whole bunch of webinars and information and details on this, so please leave us know afterwards if you need any further information. In this case, last thing I mentioned is that I have saved this file into a specific folder. So if I was to go File, Save As, you can see I've got a folder called Webinar ArchNZ. So as we create the plan views, we will show you how they get populated into the same folder. So let's go to the point cloud tab. So in here, you can see an extensive range of options. We won't go through all these today. Because I'm in the BIM version of our software, we have all the options available. If you're on the Pro version, you wouldn't have all these building commands. They're specific to the actual BIM side. So if I was to attach a point cloud from scratch, I will get the option to import a bunch of very familiar file formats. So E57 and RCP, RCS are the most popular formats. We also do LAS, PTS, and HSPC as well. So once these get imported, we convert them to our own format, which makes it extremely efficient. So this is my folder of my existing imports. If I go to my cache settings here, you will see we got the option to click on the storage locations. In my case, I've got two. I've got my standard C drive default location. I've also got my external drive. As we know, point clouds can be very large files. So to keep my hard disk free from too much clutter, I also use an external disk. So these can be network locations too. So as you do this, you can have multiple options at the same time. So without any further ado, let's bring in one of these point clouds. So I've got one. Let me find the one I want here. Click on insert, and I will insert that into default coordinates. So if I go to my plan view here, I can see this point cloud. This one doesn't have color, so you can see it's just a point cloud with a whole bunch of geometry. So to change the colors, I can do everything from the quad. So I can hover over here and use the quad options for point cloud to access all these functions. I can also do it from my ribbon. So I'll do a combination of both. It's personal preference on which one you use. People often find the quad a bit confusing, so I'll use the ribbon a little bit as well. I've clicked on color map here, so I can say I want to show this in different variations of displays. I'll click on intensities just so we can easily see the colors here. Press close. We could do elevation, color coding, etc. We'll keep this very simple. At this stage, what you'll see is the point cloud and the bubbles show up as well. So on these bubbles, if I click on one of these, I get the view from that area. Now we can do a lot with this. We do have a separate workflow where we use this fit planar command and we extract individual walls as flat planes. What you can also do is if you run the polyline command, the standard polyline command, in here you can then draw on the actual walls, and you will see as we zoom in here how it adapts to the face of the point cloud. You can put text and geometry on the file, and that thing gets created in model space. These are workflows that we've done in other sessions, so we can make you aware of those separately. What we're doing today really is a very quick version of extracting the geometry in a very short time. So first thing we'll do is line this up. So let's go to our point cloud align command here. What you do is you make a selection of an area which contains plenty of walls, so the software can look at the orthogonal nature of those. When you do this, you get the option to rotate the geometry or do a UCS. I'll rotate, and if I did a UCS, I could have multiple versions. So if my building was more complex, where we had different orientations, I could have different scenarios for those areas. In this case, it's a very orthogonal XY orientated situation, so this works quite well. I will rotate this so it'll work horizontally across my sheet for my final plan view. And now we are ready to start working this out. So I'll quickly mention, excuse me, I'll quickly mention some of these cropping commands, because if you were doing this job for serious production, you would make some checks so you can verify that the software is getting the correct values. So I'll click on point cloud crop rectangular, and I'll just draw a rectangle like this. And I'll click on inside it. Sorry, 1 second. Point cloud crop rectangular. So by cropping it, well, I've done something wrong here. I'll give it one more go. Okay, what we then do is go to the front view, and in here you can accurately identify the elevations of the floor, of the roof, and of the windowsill levels, etc. Now in my case, this isn't a production job, so I'm not too concerned about getting it accurate, but I'll accept the defaults that the software suggests. But if you were doing it more serious, you would go and check those before you start doing the work. What I will do is click on Point Cloud Detect Floors. And when I click on this, it asks me which part of the point cloud to use. I'll say use all of it. And when it does this, it asks me, do you wish to create spatial elements? I'll click on yes. And what I've now got are my floor elevations inserted here onto my story bar on the left-hand side of my screen. So if I click on the house icon on the top left, that will give me an indication of which levels have been selected for this. So we can obviously change these here. So it's interpreting 72.08 for the floor 2 and 69.72 for floor 1. So with those set up, I can now start interrogating my drawing. So if I click on this floor here, what it will do is switch to an orthogonal view, so we're no longer in perspective, and it shows a clipped 2D interpretation of that point cloud, which is quite interesting. So we're still in our 3D environment, but we've taken a 2D section. And this is quite interactive. So what it's doing is taking a thin slice of a point cloud, which I can control here. So on the left-hand side, as I drag up and down on my story bar, I'm controlling how much of the point cloud is being cropped, which is very useful for having the correct elevation for things like windows, etc. And then it means that on plan view, you can go and work through the process. Now, very quickly, if I was to exit this view, in here, if I was to start drawing some polylines, so I've got my snaps turned on. So we do have a dedicated snap for point clouds. So this isn't like using a node snap. This is a dedicated point cloud nearest point snap. So if I do a polyline, if I snap, so if I was in a plan extraction, I snap to a point here, and I'll do another one where I'll snap to a point around here. These two lines have got different elevations. So this one's got an elevation of 74.35, and this one's got an elevation of 75.23. Because we're obviously snapping to various random point clouds, random Z elevations on our area. And what's interesting here is when you're on this view, the Z value is controlled by the floor elevation. So if I was now to do the same thing, where I will do a polyline, I'll snap here, and I'll zoom in here and make sure I'm snapping to somewhere on this wall. Both of these polylines have got the same elevation, which is governed by that floor elevation. So what we're doing is giving us the option to snap to the XY coordinates of the point cloud section and take the Z value from the elevation we specified. So we've got people who are happy with that. They're glad to be able to just quickly draw the polylines manually here. We've got a much better option, which is we use the quick wall command. So on the modeling tab, we showed you quick draw earlier. This is quick wall. When you click on this, it's going to draw some walls for us. And we've clicked on a free length of 1 meter, which we'll show in a second. The most important thing to be aware of here is the auto detect wall thickness. So that gives you the option to detect a wall from existing polylines or from a point cloud. So if I zoom in here, I can click on this area. You can see how it adapts the wall thickness from the point cloud. So as I move around different parts of my drawing, these will automatically adapt to the thickness. If I press the Control key, I switch to a north-south orientation. And again, I just click on the various walls that are of interest. So let's grab a few of these. And we're not going to do all of this. We'll just do a few so we can see the concept. Let me find a few thinner walls along here. Obviously, the quality of your point cloud makes a big difference to how effectively this works. So I'll just click on enough here so we get the overall shape of the building. And I'll do one more here. Okay, and what we're going to do next is join all these segments up. If you were doing this job as full production, you would obviously work around and do all of those samples. For the external walls, in our case, we don't have the outside. So what we'll do is click on the quick draw command. And in here, you would type in the correct wall width. I'll assume it's 0.43. And what we'll do is we'll snap to the point cloud for the outside here. And then we work our way down to here and snap to this area. Now what we can now do is combine the snapping with the magnetic snaps. So you can see how the cursor has given me the option to use the existing wall as a reference, existing internal wall I mean. And now I can do that recess option that we mentioned earlier. And I can then snap to the point cloud to click on the second side of this. So let's do the same thing for the bottom. And this gives us the general shape of the building exterior. So with that done, what we've done so far is we've created very quickly a representative sample of the internal walls and the external walls and slab. So let's just quickly hide a few of these to make it easier to see what we're doing. So we go into our building, we will hide the slab. So we'll hide that. You can see how everything's being categorized automatically as we go through. I'll also hide my point cloud very quickly. So in standard traditional BricsCAD, the way you would now go about this is you would take one of these solids and use various commands to either manually push-pull the walls to specific areas, or click on this command here to extend and connect with the nearest face, which is great, but people have pointed out that they prefer to work on 2D plan views for these. So on the more recent versions of the software, we've got two very relevant commands. We've got BIM trim and BIM extend, and these behave exactly like the standard 2D trim and extend commands. So if I hover over one of these walls, I will see under the quad the options for BIM trim and BIM extend. This is why we like the quad. As you hover over the entity, it prompts you with exactly the functions that you need. This learns from what you do and gives you more relevant commands as you use the software more often. So I click on BIM extend, and this will extend out until it meets that wall. I can then press enter to repeat the command, so I can very quickly go around my screen and just do a whole bunch of these. So if I make a mistake, obviously I can undo any of these. I wanted to push this wall up here. We will do a few variations on this as we go on as well. So I've skipped most of the walls here, but we got enough to give ourselves a taste of it. The way the BIM trim command works is you hover over the area you want to trim and click on the trim option, and it will trim these for us. So very, very simple to use. You'll notice that most of the corners have been put together with these miter options. If you wanted to change any of these, you can select one wall and click on the L connect option, pick the second wall, and you get presented with a bunch of options for how the corner is rationalized. You press the control key and you cycle through those and press enter when you get to the one that you want. So you can very quickly build up a basic view, which is a great starting point. What you would then do is go and, well, we'll put the doors in next, but let's say that we had some more complex walls. Now, in this case, we don't. All the walls are very orthogonal. And this is actually a door here, but let's just pretend that this line here was actually a wall, or the start of a wall. As well as using the quick BIM wall command, you can type in BIM wall. And when you type this in, you can draw a shape here. Now, as you draw this, you can see at the moment it's got it correct. If I was to press the control key, it switched to a centerline option, or it will snap to the left or the right. So with this, you can draw and snap to the point cloud for your non-orthogonal walls. You'll also see the option to put in arcs. So as you draw these arcs, this wall will come in. So once that's done, you can do various things, or you can still run the standard BIM trim, BIM extend commands. So click on BIM extend and put that wall in here. Let's do the same thing over here. BIM extend and have these rationalize and form a wall. This wall doesn't make much sense, but we leave it here as an example of what we can do with some more complex areas. So some people are happy with this. They're saying, okay, the only thing I want to automate is the walls. I've got existing blocks for my doors and windows, which I can just put in my 2D drafting team. So all they want to do is quickly extract these and then explode a 2D section output and go from there, which great, that's a good starting point. We will do a bit more here with the automated tools, but we're happy to work with existing workflows and existing libraries as well, of course. So the next thing we want to do is extract some of the windows. And at the moment we can't see them because our walls are blocking them. So what we can do is grab all the walls here, just do a quick selection using the browser, and go to our properties and change the transparency to, let's make it 90%. So now we can see where the windows are through the actual wall. Same with the doors. So we can see we got some doors down here. Now we should go and measure one of these doors and do it correctly. I'll just do a rough version of it. So I'm going to use our library here where we've got a whole range of existing components. If you wanted to use your own components, you can type in BIM insert. And as well as inserting drawing files, you can also insert RFAs. So if you've got Revit families of doors or windows or whatever you need, you can insert those. We've got some IKEA exports here for various kinds of tables and furniture, which we can put in a while. So you can extend your options with those. In the interest of time, I will just use our standard options. So I'll go to a door here and I will click on a single swing door. And when you do this, it asks you for some dimensions on the bottom. So I think mine is 1.3 roughly width. So let's go and place that door in here. So as you hover over the wall, you can see how it snaps that for you and it puts this door in. Now, if the size is incorrect, you can grab that door afterwards, go to your properties, and right down the end, you can change all these values to whatever you need. You can also do it interactively while inserting, which we'll show on the windows. In this case, it's put it in with the correct orientation. If it hadn't, you would hover over the wall and use the quad to switch it from internal to external or from left to right as you need. So let's put this back to how it was. And what you normally do is get it correct once, and if that door is then repeated throughout the building, which is an ideal scenario, you can hover over it and click on the insert command, and we'll take those parameters and let you copy it around the file. So I'll assume that these are the same, that they're actually slightly different, but let's just, for the sake of speed, let's put these in. I'm not too concerned about getting it accurate here. As you go through this, of course, you can then go and select these and flip them as needed. So as long as you're hovering over the correct entity, you get the option to flip these and work through what you need. So that's how you can quickly insert a bunch of doors. Let's do the same thing for windows. Now, when we first of all took our front view of the point cloud, we would have measured the height from the slab to the sill of our window. So as we insert these windows, it's going to ask us for that value. So we'll go to the same panel for the library. This time we'll go back to our root and click on windows. You can see we've got a bunch of different window types here. Let's click on a very basic one. And again, it asks us for a bunch of dimensions for the width and the height, etc. I'll do it slightly differently this time. I will hover over here, and this time instead of typing in the value on the properties, I press my control key and I can interactively type in the value here. So I made this one say 1.3 to 1.3 and press enter. So now when I place that in, it will take those dimensions. And again, you would go to the trouble of getting it correct once, and then you can keep on working from there afterwards. So in my case, I think my section height might be incorrect. Let's just go here, and if I drag this up here, I can see exactly where my section is going to be taken. So this is the benefit of the story bar. You can change the extent of your section to suit what you need. So because I clicked on 1 meter for my sill height, that was taking the value from here. So actually, I may have skipped over that a bit quickly. Let me just remind you that when you click on the window command here, it does ask you for the sill height up here. So because I clicked on 1 meter, that was why my section view was too low. So you would bring in as many of these as you need. Again, I'll just do a few here. We'll switch to a file where we put them in more carefully later on. So at that point, we have created enough of our file to do a representative sample. So we can now start looking at our options for final production. So let's go and exit this section view. So we go back into our overall perspective view. We will also turn off our transparency. So let's grab these walls again very quickly. And go to our properties, and we will turn off that transparency option. We'll switch this back to by layer. And we'll also turn the point cloud off, just so we can really see what's happening very easily. We'll turn the slab back on. Okay. We've got a bit of time here, so let me just show you an example. If I was to go to that BIM insert command and go to one of these Revit families, if I clicked on, say, any of these table and 5 chairs, for example, when you insert this, you can now place that anywhere you want in the drawing. So let's place that here somewhere. You can see how easy it is to insert the Revit files. So I won't do too many of these, but once you bring them in, you can, to your heart's content, select these and move them around. So what we'll do instead is focus on how we're going to generate our spaces and our sections and everything else for our plan views. Because we could easily go and select File, Export, and Export to IFC. So for the Scan to BIM side, where we've done the basics to get started, what we're going to focus on now is the Scan to Plan side. So let's run the BIMify command. So we go back to this view here, we type in BIMIFY. This is the command to automate a bunch of manual steps that we would have to do now. So when you run the command, if we had drawn geometry using solids, it would interpret those and offer to auto-detect what they were and convert them into walls or whatever was needed. So it's clever enough to realize what a slab looks like and what a wall looks like for orientations and offer you the option to add BIM properties for IFC to those. We'll also create spaces, which we will leave turned on, and most importantly, it will create section views and elevations for us. So if I click on apply here, it runs through the drawing, and it doesn't have too much to do here because we've already applied the BIM properties. You can see how it's made all these spaces for us. You can grab any one of these spaces here, and actually let's grab a few of them. Let's click on these two here. And when you go to the properties, you can change the name here from space to, let's say, storage. So storage, et cetera, to actually define those spaces. More importantly for us, it's also made elevation views and section views for us. So if I double click that section view, I can see what's happened here. It's created a view which I can also select and adjust the positioning of to suit what I need. And you can see how that's going through our various windows and doors. So what we're going to do fundamentally is extract that section view into a new drawing. So you could just do a block extract onto the current drawing, but it's often tidier to build a brand new drawing. So at this stage, we're ready to go with that. So we can do it in different ways, but the quickest way is to use the project browser. What this will do is ask us a bunch of questions and use that to populate a title block of a drawing sheet. So I will change my project name. Actually, I'll leave it as, say, ArchNZ. I will change my number to 1565, call it phase A. I won't do too many of these. I'll just I'll leave it at that stage. So you would populate these, and what you would then do is go to your sheets, and you would click on create new sheets. And when you make a new sheet, you can drag and drop various views into that. So you could do that manually, or what you could do is go to your sections view here, grab the floor you want, and click on create sheets. This gives you a wizard type view where you can click on the scale you want and see exactly how that will look on the sheet size that we've picked. We've got an A1 sheet here, so we're looking at a 1:100 scale. You could also add the elevations here, but we're just doing scan to plan at this stage. So you click on create, and that goes and builds that sheet here for us. So if I now go and look at that floor, and I can right click and update, this is our final sheet produced. You can see how the title block has been populated with those values that we've put in. And this gives us the basic output that we need. So some people like to go and take that and explode it and just work from standard CAD dimensions, which of course you can do. We will do a better option than that to begin with. But before we do it, let me just show you what's happened here. We mentioned earlier that we had saved that file onto its own folder. So this is the file that we started with. Because I've run my browser now on my project, it's made a subfolder called Sheets, and it's put this sheet inside here. So I'm now working off this file here. So obviously somebody else could work off that. What's actually happening here in the background is on the model space, there's a very, very interactive block happening here. So this is a standard block, but it's super clever in the fact that if I was to go and make changes to my source file, this will update like an XREF. So let's do a few of those. So the best way to show this is to go and put some dimensions on and some labels. So let's make some more space here. We've got a command under the annotate tab called BIM dimension. So if you click on this option, you can get quite interactive where you filter entities. So you could filter by, say, wall type and just do everything in one click. It's often faster just to do place dimensions and just select the walls that are relevant. So let's just click on these external walls here, press enter. So we can put in an overall dimension, we can press control and do subdimensions and show as many of these as we need. So it's just a lot quicker to run it that way. What we can also do is label those spaces. So let's go up here to our manual tags and we call this space here storage. So you can see how that one shows up. This one didn't have a name yet, it was called just basic space. We can also label the doors and windows. So depending on what information is stored on the doors, if you click on these, oh sorry, that was a space. Let's click on the actual, we zoom in and make sure we click on the door. Click on tag manual and click on the actual door here. You can see that shows up as a certain door type. As you do these, you can change this output. So let's just do that once more. Keep on clicking on the wrong area. Let's click on the door here. If you press the control key, you can show this in different levels of detail depending on what you want to display. So same works for the windows, etc. You can see how we have made a 2D extraction of that IKEA furniture as well. The file stored a 2D plan view as well as the 3D model. So we have quickly built up the plan view that we're after for quick production. Now, if I was to go back into my original file and let's just make a few changes, let's change this from storage to something else. Let's call this, where's my option here? We got storage, let's call this bedroom. What we can also do is let's click on this wall here. You can see how it gives us options here. I'm going to do something a little bit radical. I'm going to change this to say 4 meters. So this is a bit of a contradiction in terms, and I'm changing what I did from my original scan to plan. I could also draw some new walls, some new geometry. When I go in here and when I click on my viewport, I got an option here to refresh. Click on update section and you will see everything updates. So that wall moves and the text changes as well from bedroom to floor. I would then go and update my spaces so that these apply to the new geometry as well. So you can see how the plan view is interactive, and as you add new geometry to your area, these will update. You wouldn't normally move these walls, of course, because it's a scan of an existing building, but this gives us the outputs that we need. So if we were to go back to the original one that we started with, this was the version that we had here, and you can see in here that we got different color codings turned on. So when you select the viewport, you got an option here. Let's just pick that viewport. You got an option here called typed plan. And you can see how we've got EXT red selected, which is show external walls in red. If I change that, I got different options for LOD. I got, say, area colored plan in meters. What this one will do when I refresh this is it will color code those spaces via area. So the hall should be the largest area, and you can see how you have different ranges set up here. We can also do a variation on that where all of the space types will get shown with different colors. So if we go to area function and click on this, refresh. So what this is doing is it will color code the hall in one color. So the hall is color coded green, the bedrooms are color coded in yellow, etc., etc. So I won't go through all of these, but the reason these work is on our file section, we've got a bunch of typed plans included on this file. The software ships with a bunch of these. So to work with any of these, you click on the plus button and you can click on new type plan or import. Now what I always do is import an existing one. So some of these come in. So to make the color coding for area function, what I did was I started with the included version, which was the area plan. You can see here that what it's doing is saying find the geometry where it's a BIM space and select where the floor is less than a certain amount and greater than a certain amount. And for each of these, apply a certain color and a certain hatching pattern. So it's quite simple to use. All I did was take the exact same function and go to, instead of doing by area, I say BIM type is space and the name is staircase or kitchen or living area, etc. Then apply various colors to these. I did a variation too where you say just show living areas in this case magenta and everything else is default. So if I was to go and select this plan view and switch it to area living areas only, click on refresh, that's just going to show the functions, sorry, the living areas in magenta and the rest of it as plain. So I always tell people that these are kind of like bonus functions where you can do a lot more than the basic plan view. So one of the options is those. You can see as well in this case that we've, as well as extracting the plan view, we've also taken the front elevation, and we can show this in different levels of detail as we need as well. We've also got various extractions of the spaces with the overall floor area and the window schedule. In this case, it's only one window type, so it's pretty simple. We've got 22 of the same door type. So if it was more variations in the geometry, these would also show up, and you access those from the same place. So inside in this files area, you can see we got some schedules and we got some templates showing up. So if I click on, say, my door schedule, all you do is drag these across into this space here. And again, to create these, you can go and say create. You could do a new schedule if you want, or just import. And when you import, you've got a bunch of defaults that you can bring across as a starting point. To change these, it's the exact same as what we showed earlier. You double click, and what you have effectively is a spreadsheet type view where you've got various parameters you can add here. So you could add new if you wanted. And again, there's a whole bunch of data stored with all these IFCs. So if you wanted to show acoustic ratings or any of the other values that you need, you can bring those in. So I won't go through all these now, but you can see how quickly you can bring those across. So the benefit of not exploding the view and working with the actual data component gives you a lot more flexibility. So just to show what we did from scratch, just so you're aware of it, this was the point that we started with. And this was where we did the same geometry as I went through in this webinar, but we put some more effort into it where we extracted all the walls and all the windows. So once that was done, we ran the automatic version where we produced this BIM type output where these dimensions are in paper space, but they interact with the model space version. We also show that if you wished, you could go and do this manually, where you got your existing dimension styles. So your drafting team can just take that geometry and work through those areas. So we've covered quite a lot in a pretty short time, but the main thing to point out is that the BIM wall command will get you what you need for the basic building footprint very, very quickly, and then you can add your section views interactively or manually. So as you mentioned earlier, we got plenty of online resources to go through all these. If you can't find these, please leave us know. If you search for scan to plan and BIM wall, that will get you most of what you need, I think. So with that, let me pass back to Kirsty, and we'd be very happy to take any questions you might have. We've got a few more minutes left, I think.
Thank you for that. If you could just change the presenter on your end, that'd be great.
Okay. Is that working? Right click, make presenter. Here we go.
And thank you. So it looks like we haven't had any questions come through yet. I'll give it another minute if anyone else has any questions coming through. Have you come across any functions that have been used the most? Like, is there a particular one that comes up again and again? Because you showed us a lot of content there.
Yeah, look, what we're showing here is really how you can do a very, very quick and efficient version of a pretty basic scenario. So people often ask, okay, what would happen if the building isn't quite so well designed, if the walls aren't quite so straight, or if the windows are at different heights or various things like those. So we can do all those. What we're doing here really is effectively automating or semi-automating as much as possible the basics. And then if it's a more complex scenario, we got a whole bunch of other tools for those, which I'm happy to show, but I think we've done enough for one session today. But if there's follow-ons, we're always available to go into those in more detail. Then
I've got.
Oh yeah.
Sorry. We did just get a question through which says you demonstrated many BIM functions. Should the same snaps and point cloud performance work in BricsCAD Pro, line extraction, etc.?
So the same snapping definitely works in Pro. The tools for walls and buildings, etc., are very BIM specific. So if you switch to the Pro software, you won't see the wall tools. What you'll see will be standard. You'll see a bunch of civil tools for tins. So if what you're doing is creating contours, we got a very nice tool for simplifying point clouds into rational numbers of points for contours. So you wouldn't have those available. Sorry, you wouldn't have the buildings. You have the point clouds. For line extraction for things like roads, we don't have an automatic feature for those just yet. I think that's what everybody wants to see, is a means of extracting center lines. I think because the center line of a road isn't distinct like the corner of a building, it's a lot more complex for software to recognize. So those aren't available just yet.
So that was a lot of great content there. Thank you very much for presenting for us. I think we'll leave it there. We haven't got, sorry, I'll just go on to the last slide. We haven't got the next content for Arch NZ well defined yet. We're aiming for September. We have a few ideas, but as always, if you have any of your own content ideas or you'd like to present, please get in contact with us via info@globalsurvey.co.nz. Any feedback as well is welcome, and if you have any questions for Sean, please also send those through. Thank you very much, everyone, for coming.
Cheers, guys.